Hi, Math 330. Today I would like to start talking about some material that's an introduction to recurrences. So recurrences 1 has to do with first order recurrences. R2R and R3R have to do with different types of second order recurrences. The R4 standard, which is optional, has to do with some higher order recurrences. But today I just want to go over some very introductory material that will kind of get you on the right footing for thinking about the notation and some basics about all of them. Now I like to start this material with some motivation for what we're going to talk about, because the application, so R1 is an optional standard, and it's about recurrences, first order recurrences, with a standard application which is to some basic money matters, which I think concern many of us. And let me say, these first two questions that I'm going to have on here have to do with savings and savings for retirement. You may not come from a family which has a lot of savings or a lot of savings for retirement, or in which this is really a thing. Your family might not be there, but our hope in getting you a college education, a computer science degree and whatnot, is that when you get to a point where you're older, you will be in a position where you have funds saved for retirement. And also we're hoping that you will very quickly be in a position, in a financial position when you get out of college, where you should be starting to think about saving for retirement. It's something that many people don't do, and many people have time to regret that later. So we're going to start with two questions about just some basic financial matters. So this first question, a person's graduating college, we're going to assume they're starting their first job at the age of 25, and that they're making enough money so that they can manage to save $3,000 per year for their retirement. Now, often what happens is that employers will match your retirement savings, and in this case, they have a 50% employer match on the $3,000. So what that means is that the employer is going to kick in half of $3,000, 50%, $1,500. So while this person is saving $3,000, they're actually seeing $4,500 saved because they get that extra $1,500 from their employer. And the first thing I want to say to you is, if you are working for a company where there is this type of an employer match, you should always put in money so that you get the money that your employer will match. Because if you don't put any money for retirement in this situation in, the employer is not going to kick anything in. The $1,500 that your employer is kicking in here is basically free money. So that's a first important thing that you should know about. So this person is in effect saving $4,500 a year, $3,000 of their own money, $1,500 which comes from their employer. Now, of course, you will also get a return on investment. We will often refer to this as interest. It can come in a different form. So if you've got money in mutual funds or in stocks, it will come in as a return on investment, not necessarily as interest, but we're going to treat it all as if it's interest. So we're assuming that they're going to get 8% annual interest. So for every year that this money is in, whatever amount you have saved for every year, you're going to get 8% of it returned to you. So in addition, you'll get that additional savings. So this person is going to make no changes over the next 40 years. And my question is, this person, now after 40 years, this person will be 65 years old, which is still considered kind of a standard retirement age or an early retirement age. How much money are they going to actually have saved in at this point? Now, I'm not expecting you to pull out a calculator or anything else. I'm just asking you to check your gut. How much money will they have? So your options are to pick from $150,000 to $200,000. So if you think that's the amount that you will have saved, choose this option. Put a check mark just down in that box right there. If you think, on the other hand, they will have more than $200,000 but less than $500,000, go ahead and check that next box right there. If you think they will have between $500,000 and $1 million, you'd pick this third box. If you think they'd have between $1 million and $1.5 million, check this next box. And on the other hand, if you think they'd have over $1.5 million, you would check that last box. So if you could just please pick an option, you don't have to tell anybody else about it, but what are your gut instincts telling you? Now I want you to take a look at the second question. Once you've had time to sit down, think about, and answer that first question. If you want to pull out a calculator, do some calculation, go ahead, do whatever you want, but find me an answer. Think about the second question. Now we have a second person and they have saved nothing. When they turn 45, the second person is going to decide to start saving for retirement, and they would like to catch up to where the first person is going to be. Now they also have a 50% match on their money, and their employer will match the first $5,000 of their savings. Assuming that this person also gets 8% annual interest. So remember, 8% of their money they gets added to their money every year. 8% of whatever they've got, they get in addition every year. How much does this person need to save each year for 20 years annually to match the prior person's retirement fund? So notice the first person has 40 years to save to get to age 65. The second person only has 20 years to save. So my question is, this first person was saving the first person was saving $3,000 a year. Will that second person need to save roughly double that amount, between $5,000 and $8,000? Or will they have to save between $8,000 and $12,000? Or will they need to save between $12,000 and $16,000? Or between $16,000 and $20,000? Or will they have to save more than $20,000 a year in order to catch up? That's my question for you. Take out a calculator, but you don't need to. All I want you to do is kind of do a gut instinct check here. Which of these answers do you think is correct? So please take a second and just answer that question. Meanwhile, so I'm just going to very quickly look at my notes on this problem. So I'd like to share with you, frequently when people ask this question, they will choose answers down in this range. And often our gut instincts tell us this answer. Well, I'm saving about $4,500 a year times 20 years, so 45 times 20. Okay, so maybe that should be in the order of maybe $200,000 to $500,000. We'll often answer here, but that's not where the actual answer is. The actual answer to this first question is more than $1.2 million, so the actual answer is in here. So we often don't understand how this compound interest idea works. The idea is that we get 8% of our money, but then the next year, when we've gotten that 8%, we also get 8% of that 8%. And the year after that, we get 8% of 8% of our 8%. It just keeps adding up. So this adds up to quite a large amount. So just saving $3,000 per year with an employer matching that for another $1,500, that will end up more than $1 million at age 65. And another question we often don't understand is this next one. If I want to catch up, how hard is that going to be? So often we don't save $3,000 a year when we're 25 because there's lots of things we want to buy, and it seems like it's really hard to save $3,000. Well, how much would we have to save when we're 45, presumably earning more money? Maybe our kids might be empty nesters or whatnot. We might have more income with which to save. And often I think the answer might come in, I think most people would answer this question with an answer of $5,000 to $8,000. But that's not the answer. The actual answer here is quite a bit more. The actual answer is more than $22,000. So if you are finding it hard to save $3,000 as a 25-year-old, I want to point out that as a 45-year-old, when you might have kids in college, even if you have kids that are out of college by then and you don't have expenses, saving more than $22,000 a year is going to be really tough. So understanding a little bit about compound growth and about how this math works, that can be important for your retirement. It can also be important for other matters because this is also the same math that goes behind things like car loans and mortgages for houses and even credit loans where you take money out on a credit card. So I think these are really important questions to be thinking about. All right. So let's continue on with those notes now that hopefully you've taken a chance to just think about those. Let's start talking about recurrences so that we know what we're talking about when we actually start to do some math problems here. So first of all, an ordered list of numbers is called a sequence. We've had sequences already a little bit in counting problems. So notations for a sequence could be a sub n, often in parentheses, or a sub k. So the indexing variable would be n or k. So if the first element would be a sub 0, the second one would be a sub 1, the third one would be a sub 2, and the 0, 1, or 2 we represent with an n or a k. Sometimes we also represent it with an a, so we could use a sub I. We don't have to use a to represent our sequence. We could use b or c, so we could also use b sub k or c sub I. The number in the n equals 4 place for sequence an, that would be the number, that's the a4 number. A sub 4, so it's a subscript. We think of a sequence as a function on the non-negative integer numbers, so we think of a sub n as being a is a function of that n. In general, the beginning term of our sequences will be a sub 0, n equals 0, or the 0th term. I will often say that's the first term rather than the 0th term, but we know that should be a sub 0. The number at spot n in our sequence where n is an integer and n is greater than or equal to 0, these would be called the non-negative integers, will be called the current term. All right. So, and we would also call that a sub n. So let's consider a sequence. This sequence starts with 1, and then you get 1/2, and then 1/4, 1/8, 1/16, and so on. Let a sub 0 equal 1, so we would say the first term is 1. What is a sub 3 and what is a sub 4? So if you could please take a look and take, I wanted to start with a sub 3, not with a sub 4. Well, let me fix that. So a sub 3, well, if that's 0, 1, 2, 3, so a sub 3 would be 1/8, and a sub 4 then would be 1/16 right there. And we can find a formula to represent this sequence. So we might note that a sub n is going to be 1 over 2 to the nth power, or 1/2 to the nth power. This formula will give us our sequence. We could also represent this sequence as a recurrence. So if we want to represent this as a recurrence, we should say that the next term is going to be half. So the current term we would say is a sub n is 1/2. The prior term is the a sub n minus 1 term. So I just want to note right here that this formula we call a recurrence. We give a n in terms of the prior term. This formula right here we would regard as a solution to the recurrence. But both of these formulas represent the sequence. Now this recurrence, this formula along with a0 equals 1, this is enough to give the sequence. The first term is 1. Then to get a1, I would take 1/2 times a0, so I would get 1/2. Then I would take 1/2 times a1, so I would get 1/4. So this represents the sequence. This also represents the sequence. This is a recurrence formula. This would be a solution formula. Once we're given the recurrence, we could find that. Sometimes it's fairly easy to find, like in this case. All right, so let's take a look at this next question. So another example, hopefully we've done an activity in class recently with M&Ms. So if we were working with the M&M death scenario, we might have started with 20 M&Ms, and then roughly half of the M&Ms would die off each time. So our initial term A0, our first term would be 20, and then our dative might have looked like, well, first we might have had 20 M&Ms, and then after some of those we died off, we would have had 12, and then 6, then 4, then 3, then 1, and then after that all of them were died off, so all the other answers would be 0. If we were to work with this sequence, we would say a sub 3, well that's 0, 1, 2, 3, so a sub 3 would be equal to 4. A sub 5 would be equal to 1. And notice that even though I might not have it listed here, I do know what a sub 10 is. So 0, 1, 2, 3, 4, 5, 6, 7, 8, everything after 6 is going to be 0, so we would know a sub 10 is 0. At that point, all of the M&Ms had died off. All right, so that pretty much completes this page of the notes.